This presentation demonstrates how to deploy SQL Server Always-On Failover Cluster over SMB shares with Azure Netapp Files. Azure Netapp Files is built as a simple-to-consume Azure native platform service with the power and reliability of Netapp ONTAP storage software. Netapp high-performance AFF enterprise systems are now available built into Azure data centers. With these systems, customers now have access to on-premises levels of high I/O and low latency in the cloud. Enable the failover feature from Server Manager. Enable failover cluster in the second server with Powershell. Validate the configuration before you create the failover cluster. Select all participated servers. Select Run Only Tests, since we don't have shared storage to validate. Unselect Storage. Unselect Add All Eligible Storage to the cluster, since we are using SMB protocol with Azure Netapp Files. Note there is no role existing at the moment. 2 servers have been added to the cluster. Installing SQL Server from the first node. Select New SQL Server Failover Cluster Installation instead of using New SQL Server Standalone Installation. Provide the failover cluster instance name. Accept SQL Server Cluster Resource Group name. Since we don't use a shared disk, select Next. Provide the SQL Server instance virtual IP address. Provide SQL Server startup credentials. SQL Server gave the warning since there is no shared disk. However, we are using SMB protocol with Azure Netapp Files. Provide Azure Netapp Files path and accept the warning. In the left Windows pane, Failover Cluster Manager, SQL Server Installation, create a SQL Server role. In the bottom left window, SQL Server places shared system databases on Azure Netapp Files. Validate that SQL Server Installer places system databases on Azure Netapp Files. In the second server, add node to SQL Server cluster by running installation. Select Add Node to SQL Server Failover Cluster. SQL Server Installer recognizes the failover cluster instance. Accept the SQL Server virtual IP. Provide SQL Server service account credentials. SQL Server Installer adds virtual IP for the Failover cluster instance. However, all Azure traffic goes through the gateway, and the gateway directs it to the servers based on the IP address that Azure knows about. We must use Azure Load Balancer to redirect virtual IPs to the server IP. Enable virtual IP in SQL Server configuration. Please note that the IP have changed from .84 to .86 to match Azure Load Balancer, which we will create next. Enable virtual IP address. Restart SQL Server from Failover Cluster Manager. Create Azure Load Balancer. Provide subscription, resource group, name, and region. Select internal as type and SKU as standard. Also provide the IP address that is created during the SQL Server installation. Create backend pools. Provide backend pool name and add the servers that are in the failover cluster. Create health probes. Provide the probe port with an unused port. In this case, we use 59999. Create load balancer rules so client can access SQL Server virtual IP. Enable floating IP. Log into the server that SQL Server resides on, and configure the health probe for cluster with Powershell script. Using SQL Server Management Studio, we can access SQL Server Virtual IP. Create user database that resides over SMB with Azure Netapp Files. Please consider these key takeaways. Azure Netapp Files is a fully managed cloud service. Just like any other Azure native service, ANF includes portal integration, access with REST APIs, the CLI or PowerShell, and associated SDKs. Azure Netapp Files is built using the power of ONTAP, the world's #1 storage operating system, with a deep install base and market-leading network-attached storage. There has never been a better time to migrate to Azure. Start your move now. Thank you for watching.